class 185. We are group number 5, and we will be showing you an odd problem today. So we are riding a scooter at 10 meters per second in the direction of 40 degrees north of west. So north of west, usually we put our axes already here. We have north, west, south, and east. We know this because later on in the problem, it'll tell us that the coordinate system is established with a positive x-axis to the east, this way. Make that positive. And then we have a positive y-axis going to the north. Then we have to find the velocity in terms of components and unit vectors. So first we're going to solve and figure out where this scooter is riding. So we're on a bird. We're going to our 8 a.m. class, a little late because we don't like waking up for 8 a.m.s. So we're going 10 meters per second in this direction because we are going north of west. And we're going to make this 40 degrees. This is northwest. Now just to clarify, we don't need to go right from the origin. We could be going this way as long as the vector is pointing in that specific direction and going at 40-degree angle. Okay, that's because vectors do not have a specific position in space. Do not forget that, very important. Probably going to be on our exam on Monday, just letting you know. And so we have that established. And so now we can find where a of x and a of y are. We need to find our scalars for this. So our scalars, we have this right here. Because this is 40 degrees, we're going to go off of this and make this our y, our a of y. And then we're going to go off of this, pick this in a different color. This shall be our a of x. Now to find our a of y, if you remember correctly, we need to use sine because a of y is going to equal sine of 40, because if we're trying to look for what a of y is, we have to remember that since it's the opposite of the angle, we're doing opposite over hypotenuse, so katoa. So we get to take this h and we get to put it right in front. And just to clarify, our h is right here, and it's also known as our component, our a vector. So that's going to equal 10. We already have that as 10 meters per second, which is also our h. That's why we're going to put 10 in front of this. So just to rewrite that to make that a little more clear. AY equals 10 sine of 40. Cool. Now we're going to solve for our a of x, which we shall use cosine because we're looking for the adjacent length of this angle. And so that's going to be a of x equals 10 cosine 40. Again, the 10 because we're looking for the adjacent sign, which is cosine is adjacent over hypotenuse, and the hypotenuse is 10, so we just multiply that to the other side. Sorry about that, guys. Okay. And now we can put this with our unit vectors on them, so we can write this in terms of components and unit vectors. So we have, stop me right there before we go any further. Our a of x is pointing in what direction? It is not pointing to the east, which is positive. It is pointing to the west. So we have to make sure when we put this into unit vectors, we have to make sure that this is going to be a negative. Or let me make that a little clearer. Negative. There we go. So we're just going to come over here, and we're going to have our velocity vector right there equal bringing down our a of x and putting these i's next to them, because these i's, this I and this j, make it to where these scalars, because right now we have them in scalars, they now become unit vectors. So now a of x is going to be, we forgot that negative, carry your negatives, negative 10 cosine 40 plus our 10 sine of 40. Perfect. Now, oh, not perfect. Forgot the unit vectors. Gonna be on the exam, guys. Don't forget to carry those. We're trying to write them in components and unit vectors. So we need that. We need that I for the x. I always goes with x. And the j. J always goes with y. And once we have done the math for these and done our little fancy dancy calculator shenanigans, we shall get negative 77.66 I plus 6.43 J. And that, my friends, is a solution to our wonderful, beautiful problem that Professor Anderson has created for us. Have a wonderful day and have a great good luck on your exam. I know that didn't make sense, but have a good one.